Now that we've laid down the historical information for property, plant, equipment, software development costs, intangible assets, and some of the other assets, let's start forecasting. So the first thing we're going to do in this video is we're going to forecast property, plant, and equipment. The management has actually provided capital expenditures forecast in their merger proxy along with all the other stuff. If you recall, they had it laid out right here. Let's just maximize that so you can see it. Summary of the projections. Not only did they give you revenue, operating income, net income, but they've also provided D&A, cash from operations, CapEx, and capitalized software development costs. So that's going to come in handy right now. So we're going to put in capital expenditure forecast from management. This basically reflects roughly a 5% growth rate, which is in line with the growth rate of revenues. So even if they hadn't provided this to us, we would have just grown it at the rate of revenues. So that's just pretty straightforward. But they did provide it to us, so we hard-coded the figures here. So that's the first step. The slightly trickier stuff is calculating depreciation. Let's just get the formula in place here. Property, plant, equipment last year plus capital expenditures this year minus depreciation. Of course, since it's going to be a negative sign, we can do the plus of what the future and minus sign is going to be there. And so now we can kind of focus on this. So first of all, we can calculate CapEx as a percentage of revenue because they've already given us a specific forecast for CapEx. And so it looks like it's 1%, 1.1% going forward. It sort of spikes up to 1.2%, and then it's back to 1.1%. On the depreciation side, this is where we have to make our own assessment because they don't actually provide forecasts explicitly for depreciation. They give us depreciation and amortization together, but nothing explicit for just depreciation for PP&E. So there are a couple of things that you can do here. So let's just kind of talk about the simplest thing you can do is to straight line the historical relationship of depreciation to CapEx, 158%. I can multiply the forecast for CapEx by that 158%. Forecast that into the future, and 9 out of 10 times that's going to be just fine. Okay, you're basically growing depreciation, and let's switch the sign here because depreciation I want identified as negative. You're basically growing depreciation at the rate that you're growing CapEx, which is actually a reasonable forecast. You know, the more equipment you buy at a certain rate, the more depreciation will grow at that same rate. Now, the issue here, this is a bit of a nuance, and we talked about this in the last video, is that because depreciation is so much greater than CapEx, you're actually getting to the point where you're virtually eliminating your PP&E. It's probably unrealistic that this company will really continue to have this relationship between CapEx and depreciation. And when it comes to an LBO, I should say that typically in an LBO what happens is if the relationship going into the LBO is such that CapEx is significantly greater than depreciation, you actually do end up assuming that the management that's now much more cash constrictor, or at least they want to bring really purchases down so that most of the excess cash can be used to pay down debt, they will bring capital expenditures down so that it becomes more in line with a one-to-one relationship between CapEx and depreciation. You know, so there's the typical best practice in an LBO model is if you have CapEx much higher than depreciation, that's the opposite of what we have here. But most of the time, CapEx is significantly higher than depreciation. What you end up wanting to do in an LBO is to bring that more in line with a one-to-one relationship, which basically implies that you're just really replacing old machines as opposed to sort of growing, you know, doing what's called discretionary CapEx, spending in a discretionary way as opposed to what's just simple basic maintenance CapEx. Now here we have the opposite situation where we started with depreciation being greater than CapEx. So if we don't want to have this somewhat nonsensical result of PP&E going down to virtually zero and potentially turning negative had the forecast been just 1 year longer, we could incorporate what's called a smoothing function, right? And a smoothing function basically says, well, you know, it's 158% now, whatever it starts out as, let's sort of in a smooth way get us to 100% by the end of the forecast period so that it is one-to-one, more in line with what you kind of see as sort of a steady state relationship between between capital expenditures and depreciation, where the company just buys new equipment to replace old equipment. And to do that, we have a formula that basically says, okay, whatever, if the user wants smoothing, So let me back up and actually say we have a little drop down menu here that says yes or no. Do I want smoothing? Okay, if I want smoothing, then basically figure out what this, 58%, take 1 minus 58%, or 1 minus 158%, which is the relationship, and you get negative 58%. And divide that by the number of periods that we have. Divide that 58% by 5 periods. And columns is a useful counter for those that took our Excel crash course know that columns is a useful way to sort of count. What is this doing here? It's saying the columns in this range, how many columns are in this range? 1, 2, 3, 4, 5. In fact, you can hit F9 to kind of see that evaluate to 5, right? And so it's dividing 58% by 5, and it's getting 11.6%, or a negative 11.6%. And so now if I create a formula in here that simply says take this ratio and subtract from that this reduction, I should say add the negative amount here. So it's subtracting, anchor that, and you'll see that it smooths the relationship such that by the end of the forecast period, we're at this sort of mature state, stable 1-to-1. That's sort of a nifty model mechanic that you see in a lot of models, especially LBO models, where you're trying to forecast towards a steady state, mature type relationship. Obviously, you don't have to do that. Some models get much fancier. Those of you who went through our financial statement modeling course recall that we built what's called a full depreciation waterfall schedule, where you estimate a useful life for all the assets, incorporate the fact that new capital expenditures will create depreciation, and try to get real scientific about what depreciation is going to look like. As I mentioned in that financial statement modeling course, most of the time, in the absence of management explicit information about the useful life of each individual asset that the company has by management, this is a little bit of a waste of time, frankly, because you don't really have the information required to make seemingly rigorous depreciation waterfall analysis actually useful, and ends up being an exercise in the same type of smoothing that we've done much more quickly here. So for those that are actually curious about the depreciation waterfall, you're welcome to kind of review the online financial statement modeling course. We go through that there. For our purposes here, this is more than enough rigor to kind of get the point across, which we're just trying to sort of smooth this result down to kind of reflect what we actually think is going to happen. Okay, in the next video, we are going to forecast software development costs. I'd like you to create these forecasts yourself here. When you're ready, move on to the next video.